So in this segment, we're going to discuss functions. They are very important in developing a good Matlab code because you can encapsulate a number of equations and relationships in one small file and put it aside, and you can call the function whenever you need it to evaluate that, so that your main program doesn't become extremely complex and difficult to review. The way that we deal with functions, we have two different possibilities. First one is if the function is simple and it just can be evaluated in one line, we usually like to contain it within the main body of the program, and we call this anonymous function. So that's one form, very simple, just write it down, and then you can evaluate it anytime within the context of your main program. The other type is to actually write a script in a file called mfile, and that script will have input and output, and then you can call that. You have to save that file in the same directory as your main program, and whenever you mention the name of the function in your main program, it would know that the file exists in the directory, and it will go and evaluate the output from the input you gave, and then it will bring it back to your main program. So these are the two ideas, and let's review them here. So the the anonymous function, the syntax is that you write f, which is the value. This is called function handle, which is the address of the function, is an f, and it knows it's the handle with this symbol, the @ sign. So if you say f and then @ sign, then in between parentheses you can put the arguments. The arguments are the input. If it is only one argument, then you have one input. If you have two arguments, it will be two independent variables. So these are basically the independent variables. And then the expression that you write here will be the function itself, how it's going to take the independent variables. We will do something on them and then produce a result, and it will store the result in the address given by the handle f. So let's take an example here. F of t is t to the power 5 e to the minus 2t cosine 3t. We have only one independent variable, which is t. We can see it everywhere here. There's nothing else, a bunch of numbers otherwise. And we want to make a anonymous function because it's very simple. There's no complications here, and therefore in the main program we write f, which is a handle, is equal to a function of t. You can kind of think about it as f of t, function of t, and then you leave a space and then you write the expression. And the expression, whenever you have exponentiation or products of variables, for example t raised to the power 5, think of t as a vector. So t vector means dot before the caret, and then the result will be a vector. T to the power 5 will be vector. So this vector will be multiplied by the next vector, which is this whole thing, which means that you have to have a dot product, a dot here before the product sign. So you have this exponential minus 2t is a vector, and therefore you have to multiply by another vector. Note that inside here 2 times t, I don't need the dot because 2 is a scalar, so it doesn't matter if I put the dot or not. It's a scalar, then it would know that it would just multiply by 2. Then once I do that, then I can evaluate. I want to evaluate this function at a number of points, which means the best way is to generate a vector at a uniform interval of 0.01 from 0 to 1, and apostrophe means that it is a column vector. And then when we say f of x, it will evaluate the value f, the function f that we defined here, at every value of x, and the result will be stored in this new variable called fx. So fx, it could be anything, could be gonim, or could be any other symbol like AA or B or fx. Here we call the fx. You could also evaluate the same function for a whole matrix. So for example, you have a matrix A, random values of at 5 by 5 matrix. Then if you say f of A, it means that you will get a matrix coming out. Matrix going in, matrix going out. Vector going in, vector going out. Single value going in, single value will also be going out. So let's, before we go into the M script, I have here a simple demonstration. Let's go here to this demonstration. Here's the f of t. You can see it on the bottom of the screen. F of t equals t to the power 5 and so on. Then if I hit return, then it will give me all what it does. It just writes back to me what the function is. And then if I define a vector t or x or whatever it is, you know, like let's say I define x here as 0 to 1 with interval 0.01, and I just left it as a row vector. So if I hit return, it will just give me the values of the row vector. Now if I want to evaluate the function at every point, let's say at 0.42, 0.43, 0.44, at every one of those I want to evaluate it, then I go back and just write the value that I want is equal to f of x. So it will take x, it will put it here, and it gives you f of x and puts it in a new vector called value. And if I hit return, the values will be right here. So this is a way to use anonymous functions in the program. The second way is a little bit more sophisticated, and it's required whenever we have dealing with a function that has multiple outputs, not only one but multiple outputs. In the past we used to call this subroutine, but now it's all a function. So you can have multiple inputs and you can have multiple outputs. For example, if you have the temperature as the only input and you have a table, and the table contains the properties of a material, say the conductivity, the viscosity, the specific heat, and so on, each one of them is a function of temperature. So you would like to have one input, T, and then you would like to have 5 outputs, which are the properties of material. Could be even more than 5. And the way to handle this is to write a script file, and the script file you save it in an M file, and the name of the saved file should be the same name as the function. So the syntax is like this: function of output. So function, it has argument out1 and out2 and out_m. So you have m arguments out, and you give it a name, and then in between parentheses you put any number of inputs. For example, if we have only temperature, it would be like one input here, and then we could have viscosity, conductivity, and so on the left hand side. So that's kind of the general syntax, and here's a way, the easier way to look at it. This is a very simple script file. If I don't have many outputs, I have only one output and several input, then I can do it like this. The first line is the word function, and then you give it a name, and then you can just z would be actually the function of the independent variables x and y. So the operations to be made on x and y is that we can make x into 3x and put it into u, and then z we can construct it from u and y as well, and then we should have an end here, and this will be an m file for the function z. Whenever we call it and we put any numbers x and y, we will get a number out that is called z. So this is a simpler form. if we have one a dependent variable and several independent variables. The other way is if we have, say, a number of input variables, in this case only one, the radius of a circle. Let's say a circle has a radius r. Then I would like to have two things. I would like to have the area, which is a function of r, and I would like to have the perimeter. The area is pi r squared, and the perimeter is 2 pi r. So these are two different outputs. And the easy way to do it is that I have a declaration statement for the function. And A is the area, C is the perimeter. And this is the name of the function. We're going to call it name and circle, and we're going to store it in a file called circle.m. And that is the independent variable here. And I should have an end here to terminate the m file. And whenever I use it in the main program, I just simply call circle of 4, and the results will be stored in A and C. And you can see here A and C. So I will just again to make it a little bit more concrete, we will see how we would do it in Matlab. So in Matlab, let's say we have the function that we constructed, and the function we constructed is right here. So you can see it in the middle of the screen. I constructed an m file. You see circle.m, and the first statement, whenever you say new, let's say, and it asks you for a function, when you click function, then it will make immediately the declarations for you. So function, and it will let you put in your arguments here, and then you can put the title here that you want, and then you have the input arguments, and then end. So I don't need this because I did it already, and I just need the function that I made, which is a circle, and I put the equations that calculate A and C. So the input is 1, and then the output is 2, A and C. And I saved it in the same directory. So now it knows it is in the same directory. So let's see if we go to try to use it. And when we try to use it, I can reach it by maybe going to, you see the statement here, I wrote AA, comma CC. These are two new variables that I define. What are the values? The values will be obtained from the function circle, and the input is 4. 4 is the radius. So when I hit return, it should give me two numbers for AA and CC. If I make the same statement, but I change this to 40, then I will get two different numbers for AA and CC. These are the area. This is the area, and you notice that this is the E format, and this is the perimeter for that particular circle. So that's kind of a good demonstration for how we use the script file, m file, to construct an external function that we could use. I'm going to go over a little bit more advanced example on a function and discuss it before we move on to the next topic. So here we have a situation where we want to plot and or we want to construct a function of 3 variables, x and c and a. C and A are what we call parameter. In other words, they can take some limited number of values, but x is the main independent variable, which can be, let's say, a whole vector from 0 to 100 with increments of 1. So you have a whole bunch of things in x, and we want to find the corresponding results and put it in a function, and the function is exponential minus a times x minus c square sine x. So you can see x is here and X is here. But you have the parameters A and C stuck in there. So we want to design kind of a function that has multiple outputs, and the multiple outputs will be output 1 will be the value of the function itself, and output 2 will be its derivative of the function. And the derivative of function, I can just take the derivative of this function, and I find that the derivative is something long. So right here is the derivative analytically. So somebody calculated it or derived it, and I have the expression, and I would like just to program it. So the two outputs are the value of the function and its derivative. The inputs, I would like to have them. I would like to have the choice either to input X by itself, X and A and C, all of the three together. So I'd like to have this opportunity. So the rules that I have been given is that if X is the only input, then I must set C to 0 and A to 1. If I have two inputs, X and C, then I must set A equals 1. And if I have only one output argument is calculated, so in this case I just want to design the function depending on the number of input arguments or output arguments. So there is we can access this through the variable n_arg_in. So this is the number of arguments in, or n_arg_out. These are the numbers of arguments out. So in this case, if you look at the flow of the syntax here, we're implementing what we've been told. So if the number of arguments is equal to 1, notice that you have equal because this is a logical statement, logical. So if n_arg is equal to 1, it means that if this happens, if it is true, then you set C equals 0 and you set A equals 1. Else if, which means it's not true, then you check on the number of arguments in again. If you find it 2, then you set A equals 1 only. End, because an if must end. So with every if, you have to have an end. And then once you have this condition, then you can put argument out 1. Then you have another if statement on the number of arguments in, number of arguments out, depending on what you want. So if the number of arguments out equals to 2, then you write an equation for out 2, and therefore you have two outputs at that time. So the example basically shows us that we could construct a relatively sophisticated function that knows how many input arguments it will have and how many output arguments it will deliver, and depending on any conditions you wish on the input and the output, you will get the results that are desired. In this case is two different results. Out 1 is the value of the function, out 2 is the derivative. You could in fact put as many outputs as you want in the program of this M file. So with that, I think we have covered the section on programming with M files, and we will see that this is going to be very, very useful for the development of more sophisticated and better structured